Hello and welcome back to another video on this channel. In this course, I'll guide you through the entire process of creating your very own mobile idle game from scratch. You will learn the core mechanics that make idle games so engaging, step-by-step implementation to bring your game to life, and how to implement the basic idle game mechanic, including saving and loading your world. Now, this is just the beginning. There will always be a room for improvement and customization, but if you master the basics, you'll have a perfect foundation to create something very unique. So let's dive right into it. I created a new project with a 3D mobile template, and then got rid of some of these basic files like the readme or the tutorial info or input system, and added some folders to organize myself. Now, as always, I will import some assets from Kenny's. Link to this dude is in the video description. Now we got some super fancy objects like a barrel or a cool floor with the stones and a little character. Pretty cool. And for the UI, we also have some pretty cool textures. For example, these blue buttons, the canvas. I think we can work with that. Let's have an idle game where you are in a dungeon and have some orcs or humans that have to break stones, and you can increase the level of these humans or the level of these stones to gather more resources to expand your dungeon or something like that. So let's start with the fun stuff. I think I'll draw the dungeon first and make it visually appealing. And yeah, then we can do the other stuff. So I click right in the hierarchy and create empty and call it world. Then I know, okay, this is the 3D world we have here. And then, yeah, start putting things into the scene. I just create a little scene and then we have a look if it's good enough. Okay, what happened here? I deleted the global volume, I changed the directional light to have the color blue and reduced its intensity, and then I just painted around with these objects and put everything under the world game object. I then clicked on the camera and choose game object and align with view to have also the camera aligned with the scene view, and I think this is okay. So our next step is to create a camera controller so that we can move around the scene and can zoom in and can zoom out. But before we move on, I want to import some things from a previous tutorial to add some ambient to the scene. Therefore, I will create a folder called scripts, world, and in there I put the flickering light effect. And using this effect, we can add a torch also. So let's create a torch, cube. This is scale of 0.05 is okay, I think. 0.05 again on the Z axis and 0.2 for the length. So let's zoom in, call this torch, go to assets, create a new folder to stay organized and call it materials. And here we can say, okay, this is some kind of, I don't know, a prop. So this is the prop folder. And in here we can add a material and say, okay, this is wood, because we want to reuse that later. So let's see, this is a good color. The smoothness is 0. And we do not adjust these settings. Of course, it will help to increase the performance, but we stay basic in this case and just assign the torch. We do not need the box collider on that. And also now we want to create the particle effect for this one. And then I create a prefab folder, also a world folder. And then I'll drag and drop the torch right into it. What I also want to do is create the background. I do not want to use a skybox for that. So I choose the main camera and then go to environment. And instead of skybox, I just take solid color. And then I'll just pick a color that I like. This one is pretty good. And we want to have it a bit darker so we can see our ground. Yes, I think that's okay. For now, maybe later we want to create a custom skybox, but for now this is okay. Cool, so now we have our pretty cool scene. And now we jump right into the camera controller to move and pan around and zoom in and zoom out in our scene. So let's create a script called camera controller and make sure that this is in the scripts folder we created earlier to stay organized, because Unity tends to create these scripts in the base asset folder and we do not want this. So I just drag and drop this into scripts, and might also create another folder called controller to stay really organized, because this project will be pretty big and this really helps us to find stuff again. Before we start writing code, we want to have knowledge about the bounds we have. So let's choose the main camera and just play around with the X and the Z value until you are familiar with the bounds. In this case, I see, okay, we're about -1. So I know, okay, -1 will be the minimum of X amount, and then we can play around a little bit more. Okay, right here, yeah, I think 8 is okay. So we have an 8 right here. And for the Z, we do the exact same. We choose, okay, how far are we allowing the player to move? And I think 8 is okay right here. It would be funny if -1 is also good right here. So let's have a little check. But it seems so that -1 right here is also okay. Cool. So we know that our bounds are at 8 and -1 for our camera on both X and Z axis. This is important for later, but right now we're just going right into our camera controller. Right here. So to get rid of this ugly error, we want to have a namespace here called controller. Nice. And copy this one right here. Cool. Okay, so what do we need? As I already said, we need the bounds, so let's just write them down real quick. Okay, so what do we have here? We have the header to see in the inspector what this category is. Then we have the serialized field, so we can access this private variable in the inspector, and our variables with default values, which we found out. So in the inspector, you can see, okay, we have this camera map bounds with the category header and all variables, which we can access right here. What else do we need? We also want to zoom in and zoom out, like in the tutorial I provided, I think last week, I guess. So we just use the code from there. So this is exactly the same as in the tutorial I provided. The minimum zoom, the maximum zoom, the smooth speed, and the zoom strength, which is how far we can get away from the scene, how near we can get to the scene, how fast we want to smooth out our zoom, and of course how much we have to scroll our mouse wheel, for example. What else do we need? We need a bunch of things, so let's not waste any time. We also need the camera. We also need a variable where we want to store where we first clicked or touched. This is important, so I call it vector3touchStart. Then we need the variables for our zoom. And last but not least, we want to have a cam offset so that we can use the camera perspective we have in the editor. Cool, so this is everything we need regarding the variables. So let's call the wake function and set up every variable we need. As this script is positioned on the camera component, we want to get the camera component. Then we want to get the current zoom, and we also want to get the current offset. In our update function, we want to differ between our developer input, which is on the PC and Windows, and on the player, which is on the mobile phone. So we have to create a switch statement which handles the application platform. So for now, we just want to support the Windows editor and the Android. Of course, you can add the iPhone there, but I stay very basic with the Android and the Windows editor. Now we have to create functions to handle both. So I have the private void handle mobile input and the private void handle developer input. So what can we do? We can move around by clicking, dragging around the map, and then releasing the mouse button. And also with the mouse scroll wheel, we can zoom. So I think we have 4 possibilities. And for that, we have to create if statements. So what happens when we click the mouse, what happens when we drag the mouse around, what happens when we release the mouse, and what happens when we use the mouse scroll wheel. So when we click down the mouse, we want to handle the pan start. While the mouse is pressed down, we want to handle the movement. And if we release the mouse button, we want to handle the end of the pan. After that, we want to handle the zoom. When we handle the start of the pan, we just want to store the current cam position on our touch start, but converted that to a 2D screen position. So we just want to pass in there the current mouse position. When we handle the movement of the pan, we want to just calculate the direction of our movement and add them to the current position. The Y value of the direction is 0 because we do not want to move the cam up or down. We also want to pass in here the mouse position. At the end of the pan, we want to check, okay, are we within these borders or not? If not, we want to clamp the value and make sure we stay within. The Y value of the camera position we want to have at our offset. This is to not break anything. And in the end, we just want to handle the zoom again. I just copy and paste this from my zoom tutorial. And we want to make sure to get the correct input axis of this zoom. But what happens here? We are checking if we are using the mouse wheel. If so, then we're calculating the target zoom. We're clamping this between our min and max zoom and then smoothing this value to our orthographic size so we have a smooth zoom. Back in Unity, we can play around within the map and you see, okay, we can use our pan. And also if I want to zoom, yeah, that's really, really smooth. I like that. Pretty cool. But you see, okay, this is snapping back a little bit and I do not like that. For that, I want to also encourage you to download the package DoTween. Link is in the video description. If you go to Window, Package Manager, and you do not have it, please download it from the video description and hit the plus icon right here and choose Install Package from Disk. I already have it installed in my assets and I'm about to import this to our project because this is, yeah, I would say the most valuable package in the asset store. This package allows us to animate stuff through the code and it's super duper easy. So let's switch back to our code and now we can easily type transform.doMove to the cam pose in 1 second. And we want to use the ease type outcirc. We can delete this line. And with this line, we can have a smooth snapback to the borders. We maybe want to make this duration adjustable and also use the out. I think quad is nice. Yeah, much better. So this is pretty smooth. I really like it. But we're missing one thing. We do not check if our click is over a canvas or not. So for that, we just create a canvas. It's totally okay to not have it correctly set up. But this is really important. Otherwise, the code will break. We want to make sure that our pointer is not over a GameObject within an event system. Or basically, if it is not over a UI element. Congratulations, you set up the camera controller for your development. We also need to implement the mobile input. But because we have cut down that in little functions, we can easily implement that. So at first we want to count how many touches we have. If we have 0 touches, nothing happens. If we have 1 touch, we want to pan around. And if we have 2 touches, we want to zoom in. So as I said, if we have no touch, then nothing happens. We return right here. If we have 1 touch, we can get this touch. Now similar to our journey of the mouse button, if it presses down, move around or is released, we have touch phases. So we use 3 touch phases. We use the touch phase began. We use the touch phase moved. And we use the touch phase ended. As you can imagine, we easily just use the same functions. Handle pan start, touch dot position. Handle pan move, touch position. And at the end, we don't even have to pass in a parameter. It's just pan and nice. For the zooming, it gets a bit different because we want to calculate the magnitude between two fingers, but that's also not a problem. First, we want to store 2 touches. We then want to get the delta position, which is basically the position of our touch, but in the last frame. With these values, we want to calculate the previous magnitude and the current magnitude, calculate the difference, and pass the difference in our handle zoom function. And that's it. Congratulations, you just implemented a whole camera controller for both your development and the player on his mobile phone, including zooming and panning around. Let's continue the work on the UI. As you remember, we got the canvas. We didn't set it up correctly, so let's do it now. We choose the canvas scaler that's already on the canvas object and choose for the UI scale mode, scale with screen size, and choose a resolution you like. I go by full HD. This is our main canvas. We then want to add 2 more canvas, one for the top icons and a bottom canvas for the whole menu. Let's hop onto the scene mode and click on the 2D button right here if you didn't. We then can adjust the size of the top canvas. But we also want to anchor that to the top. So I click on this little icon here, hold the Shift and the Alt key, and then press the top stretch. Let's calculate a good amount for that. So I press 1920 divided by 8, and this results to 240. So our high is 240 for the top canvas, and bottom canvas we can have a look how it's looking. And for the bottom canvas, we also want to click on that icon, press Shift and Alt, and choose Stretch Bottom. And then for the high, we can do the same, but this time we want to divide it by 4. You see, okay, that might not be enough. So let's try half the size of the screen. To check the UI in the game, we might also want to add a panel to see where our canvas is. We might want to delete it later, but just to check if the size is okay for that. So as you see, this might be a bit too much of the screen size. So let's adjust the bottom canvas manually. I think this is a good size. Let's stay with 700. We now can delete the panel of the top canvas because we do not need it. We want to have 2 UI panels here, one for the money we got or gold or something like that, and the other one is the premium currency. Again, we're clicking on this image right here and press Shift and Alt, and let's stay on the left middle side. And now we can have something like an offset here. I think 32 is okay for that one. And we do the same with the premium currency panel. We click this icon, press Shift and Alt, and then click on right middle. This time we want to have minus 32. The cool thing right here is that it is anchored to the right and this one is anchored to the left. So we can easily resize both of them. So let's do it. Let's stay with a width of 500. We can also reduce the size of the top canvas. To 150. As you remember, we got the UI icons right here. So let's import them. Let's use this button rectangle gradient right here. So to use it correctly, I just click on it and choose from the texture type. Instead of default, I want to have sprite 2D and UI. And for the sprite mode, we want to have a single. Let's choose apply. And now we can select both of these, hit this little target sign here, and choose button rectangle gradient. As you see, we now got the texture on our UI. But you see, it gets really stretched, and that's not what we want. To fix this, click on this button rectangle and install the 2D sprite package. When the installation is complete, click on Open Sprite Editor. Then you see this sprite editor window. We want to make sure that the corners stay the same while the rest is getting stretched. So let's have a look how far it is. I think 8 is okay, and then we can type 8 everywhere. Then hit apply and reassign the source image. There you go. Now we want to add some text. For example, the amount of the cash we got or the amount of premium currency we got. So for that, I hit the cash panel, press right click and then go to UI and choose text Mesh Pro. Click on Import TMP Essentials and then close this window. Let's stay basic with the font. As I do not have any kind of icon right here, I want to have the text all over the place. Again, I press this little icon here, press Shift and Alt and choose the stretch and stretch icon right here. Then on our Text Mesh Pro UI component, I want to make sure that the alignment is on the center. And then as a placeholder, I just type 0. Here I can say, okay, this is the cash label. We copy this one, move it to the premium currency and say, okay, this is the premium currency label. Again, I hit Shift, Alt and click on the stretch icon down below. And the 0 here stays also. To differ between these two panels, I just make this a bit darker or a whole different color. So the next step is to fill both of these values. So for that, we want to create a new game object, create empty, and say managers. I want to make sure that every game object that's not visible is on 0, 0, 0. Then make a child game object and call it UI Manager. Create a new component and call it UI Manager. This UI Manager will hold all UI elements so that we can change attributes and values by code. This UI Manager will be in a singleton pattern. That means then we can access one instance from every part of the code. So for that, let's create an own instance. In the awake function, we want to make sure that we set the instance instantly. But if the instance is already there, then just return. So let's add the Text Mesh Pro labels. And to set them, we also want to create a setter. Cool. So let's head back to Unity and assign both labels. To stay organized, I moved this script to the scripts folder and also create a new folder called managers. To reflect that in the code, I also want to add a namespace. To test that, we want to create a test script in a class we need later, the game manager. So let's create a new child object in the managers hierarchy here and call it game manager. Also create a new script called game manager. As I said, the UI manager is a singleton pattern, so we can access it through all parts of the code. So I just can type UI manager .instance and now we can access all public functions we have. Something like set current cache label. Let's create a new variable called current cache and increase it by 1 every frame. This is just some test code to see if this is working. So as you can see, we get it working. We can access the UI manager and set the current cache now. As you see, the current amount hits 4,000 now. And in normal idle games, you do not have a 4,000 here. You just have something like 4K. So let's add some numbers formatting for that. So let's organize ourselves. I just moved this game manager to the scripts folder and also into the manager folder and also create a new folder called helper. In here, I just create a new empty C# script called format numbers. As we want to access this everywhere, I just make it static. And this is also static because this class does not hold any state. So how should it work? At first, we want to fetch some known short characters from a dictionary. But if the number increases and increases, we just want to have it automatically. For that, we want to have the int number for the character A and increase it over the time. But first things first, let's create a dictionary first. This dictionary is type of integer and string. We want to start the dictionary with the value 0 and we want to say, okay, the first value is nothing. This string is empty, but the first 1,000 should be a K. And the next is million, billion, trillion, and so on and so forth. So let's add them. As I said, for the automatic generation, we want to have the integer value from the character A. So to start easy, we want to check if the value is below 1. If so, then return 0. What happens next? We want to determine the magnitude of the current value in terms of powers of 1,000 and then scale the value accordingly. So for that, I have a variable n, which is the math.log which takes the value as an argument, and the second argument, as I said, 1000. The second variable is m, which basically is the value divided by the power of n, where the base is 1000. This is just the placeholder for the returning unit. So now we want to check, okay, if n is smaller than the units.count, then just choose the index of that, or dictionary key in this case. Else we automatically want to determine the next value. So we want to skip the first 5 entries. That's why we subtracting the count from the n value. And because the alphabet has 26 letters, we want to have a modulo on that. We then want to divide the unit int by 26, which leaves us with the first unit. So we just want to have the first unit plus the character of a, which we defined here as a kind of type of offset to string. And then we just want to have the same again for the second unit. But this time we want to have the second unit right here. That's it basically. And then we want to return the unit, but we do not want to return the unit itself. We want to have it floored. So what does that mean? We want to have the math.floor with the m times 100 as base, and then divide it by 100. Then make sure this is correctly formatted. So we have some kind of thousandth separation, and then just add the unit we calculated. We use this because we need this to fix the rounding errors we maybe get sometimes. Cool. So if I didn't make any mistake, we can use this static format function to get a really cool UI label text right here. So let's go back to the game manager and say, okay, each frame we get 10,000 of cash, and we get a double right here. And we want to reassign the value, label value, and then just assign the label value for that. The same we can do for the premium cache label, but we don't use it, but just to make it work. So let's try it out. So as you see, million, for a short period of time you saw the K right here. So you see this is working. And to make sure that this automatic stuff is working, I just remove all of them and head back to Unity and see if this is working. Super cool. Let's take care about the input. The idea is that we have a stone that we can click, and this will increase our cash flow. Later on you can upgrade these stones or even create some characters to help you mine. So let's go to the scene, deactivate the 2D view, and drag and drop these stones in here. I just call these clickable stones and position them in the center. Also, I want to scale them up to 3, 3, 3 and add a box collider to that. I use a box collider instead of a mesh collider because it's way more performant, and also we have an increased sized hitbox. You didn't see that, but I reorganized the world, so everything else that is not clickable I put as a child for the environment game object, and I created a new game object called clickables. It's empty, so I can just drag and drop it right here. Because you want to have more than one clickable, I want to create an interface called iClickable to reuse some functions. So I go to scripts and I create a new folder called interfaces. In here I create a new script called iClickable. As this should be an interface, I'll remove everything in here. And do not use class, I use interface. And I do not want to inherit from mono behavior. So what do we want to have in this iClickable interface? We want to have a function that just says onClick. Back in the Unity engine, I click on the clickable stone and add a component and call it clickable stone. I go to the hierarchy and create a new empty game object called controller. And inside of this controllers, I just create another empty object and I call that input controller. So the goal with our input controller is to handle the clickable things we have in our scene, And for that, we want to have a camera which converts the mouse position to array, raycasts to the box collider we have on the scene, and then do some things that each game object can decide. So to cache the camera, we create a new variable called camera with a new keyword because we're overriding the camera. Then in the awake function, we want to cache it. In our update function, we also want to differ between these platforms, Windows editor we got and the Android. In the camera controller, we use the switch statement, and I think we have to refactor this later on, but for now an if statement is also okay. So for the Windows editor, we want to check, okay, do we have a mouse input? So was there a button click? And if so, then shoot a raycast straight to the point we hit, and then if it hits something, handle the clickable. So if there is no input with the mouse button, then we return right away. Then we create a ray from our cached camera with the function screen point to ray with the input of our mouse position. And here we are firing the raycast, and if it hits something, we get it out as a raycast hit variable, and it's called hit data. And if not, then it just returns. And then we want to do something with this hit data, so we create a new function called handle clickable. Basically the same we do for the Android, but instead of a mouse click, we want to check if there was some kind of a touch. I can just copy the logic from the camera controller. So we got something like check if we got any touch input. If so, then we get the first touch. And if this was the phase began, we continue with the logic we also had above. And if not, then we're just returning. We want to check if the raycast hit in GameObject, which is a clickable. For that, we're checking if the GameObject has a component with the iClickable interface. And if so, then we're executing the onClick method. So we go back to our clickable stone we created earlier, and we're just inheriting the iClickable interface, and we're adding all missing components. We can delete the start and the update function because we do not need them. And in the onClick method, we're just logging something. Heading back to Unity, let's see if this is working. So, and you see I click this button right here and it increases. Nice. To make it visually more appealing and to create the first real function, we're gonna head back to the code and animate the scale of the game object. So for that, on each click, we want to first kill the active tween if there is some tween. But before it gets killed, I want to complete that. So every time we kill the tween, the onComplete function is invoked. That's pretty neat because then we can resize it to the correct scale. And now we want to hit transform, do scale. And as you remember, our scale was 3. We just choose 2.5. And we want to have it 0.05 float. And we do not want to have any easings because it is pretty fast, so the ease wouldn't be visible at all. But we want to have a loop with 2, so it should get executed 2 times, but with a loop type of a yo-yo, so we have it forwards and back. And as I said, we want to have the onComplete function invoke, so we want to fill that with live. We have the onComplete function right here, and as I said, each time we want to rescale it to the 3 that we set earlier. So we say local scale is vector 3.1 multiplied by 3. Of course, these are magic numbers. This is not good. This is not a good practice. So we want to give ourselves the opportunity to scale it in the inspector. Much better. So let's head back right into the Unity editor. Cool. So the scale is 3. The click scale is 2.5, I guess. And the scale speed is 0.05. So let's try it out. If I hit that once, nice, it scales back and forwards, pretty cool. And if I click more than once, you see it gets set back to 3. We also want to add a real function. So for that, I create a new game object right here and call it player manager. Also create a new component called player manager. So the player manager should hold the state of the current amount of cash or current amount of premium currency or something like that. And this should be the state of, the progress that the player made. So for that, I just create a new variable called current cash and current premium currency. And then we head to the game manager and remove this here because we do not need this anymore. But we want to create a function in the player manager, which is public. And this should say increase cash, current cash. And then we just have this current cash added. That's it. But this is a pretty difficult way to have it. So I want to create a new property which automatically updates the UI on every change. So we have a getter here, which just returns the current cash. And we also have a setter here. The cool thing about that is that we can easily copy this function and put it in the setter. We can now delete this function, and every time we change this variable, the UI gets updated instantly. But we also want to make sure to have the player manager as a singleton. So we have a public static player manager called instance, and in the awake function we want to set it accordingly. So in the clickable stone, we just want to call the player manager dot instance. And then we have the current cash property here, and we just want to increase it by 1. And in game, you see I clicked it and the 1 gets added up here, and automatically the UI is getting updated, and I can click a bunch of times here, and you see each time this is, getting increased automatically. Pretty cool. Now let's take care about the shop system. We head over to Unity Engine and go to the canvas, and there we expand this and go to the bottom canvas and activate it again. In here, we want our items that we can buy. Because this space isn't enough, I want to add a scroll view for that. Because the scroll view is way too small, I'm gonna hit that icon and press Shift and Alt and use stretch and stretch right here. So we use this icon. So as we are on the scroll view component, we can go to the scroll rect and deactivate the horizontal scroll bar. When we have done that, we can go to the scroll view and delete the scroll bar for the horizontal. As we do not have any background images, we can delete the panel for now. And now let's test something. Just create a new UI image or 3 of that. It's totally okay, and drag them around and just let's see if this is working at all. So you see this is working right here. Nice. So we can delete all these images again. And then we can add the content size fitter to this content game object. So we use add component, content size fitter, and use for the vertical fit the min size. We also want to add a vertical layout group. So add component, type vertical layout group, and choose the first one you see. And now again, we want to create some UI images. I just create one, and then I just hit Control D for like 10 times. Cool. So as you see, the content gets expanded with the growing amount of images we have. So let's choose a bit more spacing for the vertical layout group, for example 50, and make the last image red to test if we can see that. So the last image we see here when scrolling should be red. So let's test this again. Very nice. So with that, we can dynamically add more things to buy because this should be our buy menu in the end. So let's start creating a shop item. So I press the right click on the content, create UI and create an image, and I call that shop item. I just think that is a right amount. I think 960 is a good width, and the high, I think we have to test that later on, but I guess that 240 is good for now. Then we go back to content and choose child alignment upper center. Maybe we also want to create a pattern for 20, 20, 20, and 20, so it's not that hard on the borders. And now we can also test that, and you see all these items are in the middle. So let's modify our shop item here. We can delete all the other items and just create some new child objects. For example, a button, a big fat buy button. So let's create a new button right here. Again, with Shift and Alt, we can move it to the middle right and anchor that to that and have an offset of 32. The button should have the price on it. I think as blue is the main color, we should have the buy button a nice blue. So let's take this button rectangle and we drag and drop it on the source image. Pretty cool. And also we want to adjust the color of the text mesh pro right here. So the vertex color is white. Of course, we can have it bigger, but I won't go into the font settings. We also do not want to have the shop item as simple white. We want to use this button rectangle right here, which does not have this gloss effect. And we want to have it a bit darker. I think this is a good amount of darkness. Also, we want to create some kind of title for that and an image to see what we are updating. But I think we go by 128 by 128. Also, we can use the same height as that to make it a bit more appealing. And then some kind of text for the title. Cool. And now we want to create a new shop item script. So we add a component right here and call it simply shop item. So we have the shop item right here. We want to assign all UI elements to a variable. So we got an image, we got a text mesh pro, which is the label for the name, and we got a buy button. We also want to have the ability to initialize that, so I create a new initialize function. So for that we want to have the item sprite. We want to have some kind of string, which is the name of the item. I call it item name. And also want to have the amount that the item costs. So let's just say this is the cost of the item or the item price. But we also need to have the item buy button text, because as you remember, we got the text mesh pro for the button. So I just use the item buy button text dot text for the item price to string. Back in the Unity editor, we can see all our fields here and we want to assign them. So the text is obviously the item label. The image is the item image and the button is the buy button. And we do not want to forget the buy button text, which is a child of the buy button. Pretty cool. And with this setup, we want to create a prefab for our shop item. So we go to the prefab folder, create a new folder called UI, and then drag and drop it right there. And then we go to our managers and create a new child game object, calling it prefab managers. And we create another child object, calling it UI prefab manager. And we can duplicate that and just call it prefab manager. For the UI prefab manager, we create a new script, calling it UI prefab manager. Like all of our managers, this also is a singleton. So we just copy and paste the typical singleton logic right here and have it as a public static field. So we can access that from everywhere. Because we want to access every prefab from everywhere, we use public variables and start with the shop item. So this is the shop item. Also, we want to stay organized and have it as UI prefabs. Or let's call it shop prefabs, because everything in here is UI. Also, we want to create a namespace for that and move it accordingly in the Unity editor. To fill this with life, I want to create a scriptable object and have 3 shop items to upgrade things accordingly. For example, just upgrade the stone to get more cash. We want to upgrade the amount of miners and maybe the quality of the miners. So let's go to scripts, create a new folder and call that scriptables. In here, now create a new scriptable object. So we had to create scripting and use scriptable object. I call that shop item SO. In here, we need for now just things that we have in our shop item UI. So that are the name, the sprite, and we need the price. So we're heading back to the Unity editor and we want to create these 3 upgrades or shop items. So we go to prefab and create a new folder and calling that shop items. Or maybe let's call it scriptable objects. And in here we have another one called shop items. Now we can hit create scriptable objects and have the shop item SO right here. I call that upgrade minus. With Control D, I'll duplicate that. And then I have here upgrade mount minus. And the last one is just the upgrade stone. Cool. So we can name that accordingly, calling it upgrade stone. Have a price of just 1, just to show that. We have that dynamically later. This is upgrade minus. And this is upgrade amount of minus. As we want to load them dynamically to have the shop item mount or updated accordingly to the amount of shop items we have here, we want to move these shop items to a new folder called resources. So we have the shop items here and we just move these to resources folder. So to load them dynamically, we have to do some steps first. First, I want to declare the content of the viewport of the scroll view to the UI manager. We also want to have a function that calls something like add to content or add to shop content. Something like a shop item. Then we can easily have the shop content instantiate that right here. In the Unity editor, I just drag and drop the content to the UI manager's new field. And then I can delete the shop item as we got that as a prefab. Now we can head to our game manager and create an awake function where all prefabs in this resources folder for the shop items are getting loaded. So in our awake function, we have a new shop item. We have a new array of shop items and call it shop items. And then as the autocomplete already says, we want to load all resources in our resources folder in the path of shop items and convert them to the shop item. But this is not a shop item. It is a shop item SO, as this is a scriptable object. Cool. So let's test that by making this variable not declared in the awake function, but in the class itself. And then in the start function, when everything is awake, we can now instantiate that. And now we get our shop item from the prefab manager and instantiate that right here instead of the shop item. And then we want to get the component of it, which is the shop item. And then we want to set the shop item by calling the initialize method. You might want to refactor this now because we just passed in every single variable, but we can easily say, okay, it is okay to just pass in the shop item SO as shop item SO and then just assign the corresponding variable. Pretty cool. So let's recap the flow because this was a bit difficult. We're loading all of our scriptable objects we created earlier in our variable called shop items. Then in the start function, when everything is already initialized, we want to go through all of these items and add them to our shop. That's why we have the add to shop content function in our UI manager. In here, we're instantiating the UI element, which we have as a prefab, saved in the UI prefab manager, and add them as a child to our shop content. And then we want to fill live in our shop item, which is the UI, with the initialize function. So let's see if this is working. Pretty cool. And as you see, these are there. Upgrade amount of minus, upgrade minus, and upgrade stone. And the cool thing about this implementation is that we can easily just copy this upgrade, and can easily add a new shop item. So I call that hello world. Then I call this here hello world, but without a typo, with a price of 3. And I just copied this one. I did nothing in the code, and then I restart the game. And then if this is working, we should have 4 shop items to buy, including the new hello world shop item. And as you see right at the start is our hello world shop item. Now we want to add an ID to all of our shop items. And to do that, we have to adjust the scriptable object itself. So let's go to script, scriptable objects, and shop item as O. In here, I just create a new public field called int, and this is just the ID. Back in the Unity editor, we go to resources, shop items, and delete the hello world scriptable object that we created earlier, and then give every single item an ID. 1, 2, and 3. Now in the hierarchy, select the upgrade manager and go to the upgrade manager script. If you do not have the script, then just click add component and create the upgrade manager script. In here, we want to load all shop items in a kind of dictionary to know the actual upgrade level of each shop item. So for that, I create the start function and try to get all shop items. As we do just have a private variable in our game manager, we want to create a public property. Also, we do not have a single pattern here, so let's just create one. And now we can create a private dictionary in the upgrade manager. As a key, we're using integer for the ID and another integer for the level. And we call that upgrade levels. And in the start function, we are getting all shop items from the game manager and iterating through it and add them to our dictionary. So as already mentioned, we're just iterating through all shop items we have loaded dynamically within the game manager and adding that with a level of 0 to our dictionary, because we want to start at 0 for each one as a default value. To get each upgrade level directly from the shop item SO, I want to create a public function called getUpgradeLevel, where we can pass in the shop item and we get the level out. So I just pass in the shop item SO as an item, and then I just return the upgrade levels with the key of the item ID. Also, I want to have a function to increase the upgrade level. So for that, I simply have the function increase upgrade level. So let's get into the math of idle games. At the most basic level, idle games are a seesaw between production rates and costs. Early on in a run, your production will exceed costs, while eventually costs will become prohibitive. This is typically accomplished by having costs grow exponentially, while production grows at a linear or polynomial rate. This is a quote from the great blog from Congregate, where the math of the idle games is getting taught. But to put this into formulas, we have some functions. We have the getCost function and getProduction function to calculate the cost for the next item in the shop and the current production rate. So the formula is that the base cost is multiplied by the growth rate powered to the current level. So it would be something like return base price multiplied by the rate growth to the power of the current level. So let's define the base price and the rate growth. As this is obviously not an integer, we want to cast that to an integer. So this is the price for the next upgrade, so the current price if you want so. To have it a bit more organized in our inspector, we want to have some kind of header in here. This is the shop details. This is the general details. And the upcoming section will be the production details. And therefore we need, as with the price, the production base. This is the most basic implementation we can do. And of course, I want to add some kind of array to that, which is called multipliers. And in here we can pass all multipliers we have. We can multiply all of that and then multiply the result of all multiplied multipliers with the base production times the current level. So we have a big number right here if we apply all multipliers we possibly want to have. So therefore I could add the logic here, but as I said, this is just I just think about the implementation. We might want to do it later, but this is the most basic implementation and I think we're good to go with that. Now we can head back to the upgrade manager and create a new function calling it upgrade shop item, and we can pass in the shop item. And here we can check if the player has more cash than the item price. Then we can increase the level and remove that cash from the player's bank account. So what happens here? We're getting the upgrade level from our getUpgradeLevel function. We get the current item price, which we calculated in our shop item scriptable object. And if we get more money than the price of the shop item, we want to remove that cash from our bank account and then increase our upgrade level with our function. Currently, we're not using these functions externally, so it's okay to have them private. Let's also change the default value from 0 to 1. Of course, this is a magic number. It would be way better practice to have something like default upgrade level and then have this as a static variable right here, private static int default upgrade level, and this is a 1. Also, we are missing the single pattern right here, so you know it, we want to add that. Heading back to the Unity editor, we can go to the resources folder, shop items, and now can adjust everything we have here. The item price here is obsolete. We do not need this anymore, but the base price of that is, let's say, 8. And the grow rate can be, I think, 8% is good enough. And the base production, I would say it's good to have that at 2, for example. And now we can programmatically add this function to the onClick event in our shop item from the UI. So therefore we just take the item buy button and choose the onClick event, and here we can add a listener to that. So we use the delegate type to call our upgrade manager .instance, and in here we can choose the upgrade shop item and pass in our shop item. So now with every click on our buy button, we have access to each shop item individually. To prove that, we want to go to our upgrade manager and call debug.log upgrade shop item, and in here we can just append the item.name. So let's head back to Unity and check if this is working. So I go to the console and now click on upgrade minus, and getting our debug log upgrade shop item, upgrade minus, upgrade stone, upgrade amount of minus. You see this is working great. So now we can interact with our shop items, but we get no notification if we have enough cash to buy that. So the button stays blue every single time. And now we want to change that. So let's head over to the player manager and create a new Unity event. And let's call that onCacheChanged. So every time the current cache gets changed, we can just invoke the current event. That's pretty cool. So now we can just subscribe to this event, and as soon as this variable changes, everyone gets notified and we can do something with that. For example, if the current cache is now lower than the shop item price, we want to color the button gray and might want to set the interactable to false. So we cannot buy anything. So let's do that. We go to our shop item and call playermanager.instance.onCacheChanged and have an add listener here. We also want to say that we want to have a double passed over. So we want to get the current cache amount. So we want to have the current cache passed into this event. And now when the event happens, we get the current amount of cache and can interact with that. So let's have a variable here called onChangeCache callback, which gets a double. Of course, this is a void. Now we can have it passed into this add listener, and just for testing purposes, we want this to print out in the debug log. So as we have 3 of these shop items, and obviously we have subscribed 3 times because every shop item has its own script, I just click this stone to get 1 cache, and because this variable changes, we should get 3 debug logs. So let's test it. Yes, as I said, we got 3 debug logs. So you know, okay, every single shop item listens to the current cache variable. Pretty cool. So instead of just logging this, we can check, okay, do we have enough money to buy that? If so, then color it white, so the original color of the sprite gets drawn, and set the button interactable to true. And if not, then color it gray and disable the functionality to press the button. So we have to access the shop item. So let's create a new variable that we can have the shop item saved in the class. I set the getUpgradeLevel function to private because we didn't need it externally, but now we need it, so public is the correct one. So what happens here? We are getting the current level, as always, with our upgrade manager. Then we're calculating the current price for the next upgrade. And then based on that, we have an inline if, which says, okay, interactable. If we have more cash than the current price, then it's interactable. Otherwise, it's not. And also, if we have more cash than we need to buy this upgrade, then it's white, which basically says that we have the original sprite. And if not, we want to have it grayed out. Also, we want to refactor the item price because we do not need it anymore because we're just calculating the price dynamically. So we can easily delete this field and you see, okay, now we have errors. This is not a problem because we want to have the current price of the next upgrade. So we have the getCurrentPrice function there. And of course, we need the current level. So let's just copy and paste it from below and paste this here, but with formatted numbers. As you remember, we have a function to help us format the current price. And because the price changes as well when we upgrade that, we also want to reset the text to the new price. So let's head back to the Unity editor and see if this is working. You see, still they are able to interact with and are white. But now when I hit the stone, we get some cash and the event is getting sent. So we have to check this at the start of the script again. But let's just hit 8. And now we have the minimum amount to upgrade our shop item. And now I hit this button. You see it turns gray again. 8 have been removed from our bank account. And when I click on the stone, it upgrades it to 9 again. So we have 2 cases more to add. We have to add the initial state of the shop item to check in the first place if this is possible to buy when the game starts, for example, and also the label is not updated when clicked, it's just updated when the new cache changed. So these are two things that we have to do now. So let's create a new function called checkInteractable and put in here cache. I just copied that from there and pasted in the checkInteractable function, and instead of new cache, I take cache and I just pass in the new cache right here. And this also happens here. So now it checks if the button is interactable at the initialize of the whole shop item. And the second one we have to fix is that the price does not update right after the update, but then when the cache gets changed again. I think the easy solution is that we just flip these both lines, because when this happens, the event gets invoked and the upgrade wasn't even executed. So if we just flip these lines, both of these bugs should be fixed. Great. As I already said in the beginning, now we cannot interact with any of these because we do have less than 8 cache. Now I press this 8 times, so I got 8 cache. And now we have 8 here, and when I click, we should have 9 in there. Great. So now let's take care of the actual idle game mechanic, so we can spawn some humans or some orcs which mine these stones and get cash over time. So for that I create a new empty game object and I call that idols. And I create 2 more manager. One is the spawn manager and the other one is the idle manager. The spawn manager is, like the name says, there for spawning the idols, so for example the humans or the orcs, within the game world to have everything after the single responsible principle. Cool. So an idea is that we can have, for example, 5 humans, and if you have 5 humans, they are getting combined to one bigger orc, which mines a bit more and visualizes a bit of the upgrade process. So for that, we might want to have an orc prefab and a human prefab. Also, we want to have the singleton pattern. So we can easily say spawn human or spawn orc. But the question is, where do we want to spawn them? So the idea is to spawn all of these idols on these 4 lines. So it's basically on 0 on the y-axis, but there's a random point on this line, on this line, on this line, or on this line. It's basically totally random, but then they are all around this stone. So to achieve that, we need to get to know the box collider. So we have a serialized field here with the box collider. And this is the, I would say, current clickable stone collider. And we have a private function here, which will return the calculated random position. So I call this calculate random position on collider. So at first we want to get the center of the collider and the size of the collider. With that we want to calculate the world center and the world size. So we have the world size and the world center, which is getting calculated with the built-in function vector scale from these collider sizes and collider center. So as I said, it's completely random on which edge the humans or orcs should getting spawned. So this is the integer edge, which is basically random between 0 and 4. Now we have 4 cases, so 0, 1, 2, or 3, which is the minimum edge for x, the maximum edge for x, the set minimum edge, and the set maximum edge. I prepared something and just copy and paste it right here. You can easily pause this video and have a look about it. I will explain one row, but it is quite similar for all of these cases. So what is happening here? Here we are calculating the x, which is basically the world center x minus the half the size of the world size x. So this is basically static. Now it comes the random between the minimum of Z and the maximum of the Z. So this is basically just a random amount between the minimum and the maximum Z. And so this is calculated for every single edge. And after that, we just want to return our position, which is in this case the vector 3, x, 0, and z. 0 because we want to stay on the ground always, which is the y-axis. And this is our function. Let's test this. We want to instantiate a human prefab on the position. This is the random position. I call it random position and just calculate the position right here. And in here, I'm just passing the random position and the quaternion identity. I also want to have a parent to that. I call this idle parent. This idle parent also should be a serialized field. Again, to organize ourselves and make our life a bit easier, we have these prefabs right here, and we also have the spawn settings right here. So to test that, we call the spawn human function right at the start of this class. But let's spawn it 10 times to check if this is working as expected. So we have 10 random positions. Back in the Unity editor, let's just create a little prefab from our human. This is our human. I think we can make it a bit smaller. Let's take half the size of that and let's call him human, with a position of 0, 0, 0, because I just like to have that centered when making a prefab. So let's go to the prefab folder, world, and now we can drag and drop the human right here and delete this human right there. Now in the spawn manager, I can drag and drop the human prefab in here and also drag the idle prefab to the idle parent, and also can drag and drop the clickable stone right here. Later on, we can also do that by just simply adding a subscribe and listen function to that to automatically get the clickable stone. But in this case, it's okay. So I started the game, and as you see, we get 10 of these human, all at a random position, and this is working as expected. Now we have to take care of the rotation of these. So to make the rotation correct, I just returned another type, so we can return position as a vector 3 and rotation as a quaternion. And I added a new variable here called rotation, and with each case I just added some 90-degree values to that and also returned this as a quaternion so that the y-axis is getting rotated, and then just as a result here and pass it into the instantiate function. And with this little adjustment, it looks like the following. So as you can see, there are these human, and they are all looking at the stone. Pretty cool. Now let's our logic that if we have like 5 human, these are combined to 1 orc. For that, I also want to create a new prefab, which is the orc itself. And I think the size of that now is totally fine, and I reset this to 0 and call this orc, and then I will drag and drop that into the world folder of our prefabs, and then delete this orc in the world and pass this orc into our spawn manager. Cool. So let's head back to our spawn manager, and there we want to count all of our humans. So let's see if we can get this done. Let's say, okay, we have a new private field, which is basically a list of game objects, and these are only human. I call this humans in world. Every single time we instantiate human, we want to add this human to our humans in world list. If humans in world dot count with the modulo of 5 equals 0, so if we have 5 left, then we want to remove 5 humans, which basically means we are dividing our amount of humans in the world by 5, and if there's no rest, then we want to remove them. So let's remove them 5 times, just 5. And in here we can easily say, okay, humans in world remove at 0. But also we want to destroy the game object so it's not in the world anymore. So humans in world. Because the 5 is a magic number, we want to have a serialized field where we can easily modify it if we want. Humans to org. Let's say 5. And if this is the case, we want to spawn an org. We can easily copy and paste this right here and just call that org and use the org prefab. And when testing this, we are spawning 2 orgs instead of 10 humans because 10 divided by 5 is 2. Great. So now we can remove this test code. Let's clean up this code by making this private, removing this game object because we do not need the access to that for now, and also having that game object right here, calling it human, and then destroy the human right here. Let's also move this spawn manager into our namespace manager. To distinguish between all these shop items we have, we might want to create a new public enum, and we call that shop item type. In here we just have the minor amount, the minor level, and the zone level, which equals to 1, 2, and 3. Let's create a new field and we call that shop item type, and we call this item type. We also want to refactor the integer key for the dictionary to a shop item. This is not a primitive type and not the best practice, but it makes our life easier later on, so we can just access this whole dictionary and get all the keys and have direct information about the shop item we want to have. Now we want to expose our dictionary, so let's type public dictionary, and we use the shop item so and int and upgrade levels, and this will be transformed into a property so we can access upgrade levels in our idle manager. So the idle manager is basically the heart of our complete project because here we are implementing the whole idle game mechanic. And we start with providing a private float with a current time because every idle game I know works on second basis. So every time you have something like 100k per second you get. So in this case, we are calculating the current time by adding the delta time. And if this exceeds 1, so we have 1 second passed, something happens. For example, we get some money. So for this, I add delta time to the current time. And as I said, if the time exceeds 1 or is 1, we want to reset the timer and want to debug log, for example. Yeah, idle is totally fine for now. So we can see that every second anything, the debug log should be printed out. So you see every second this gets printed out, and without collapse you see, okay, every second something happens. Cool. So as we added the enum types to all these upgrades, we can easily get the upgrade shop item or the shop item by its type. So let's create a new function and say get shop item by type. And now I can pass in the shop item type in here and can now iterate over the shop items we have in our game manager. And if the item type equals the type, then I want to return this item. This is not the type, this is the item type. Cool. So we can easily access the shop item by its type within this. So now we can say, okay, this is the shop item variable. It gets set here and breaks when we hit something, and then we want to return it. So this is how we can easily access this shop item by its type. Now that we can get the shop item, we can use the upgrade manager dot instance dot get shop item by type, and we want to have the shop item type at the minor amount, for example, and this is the shop item SO, calling it minor amount upgrade. And because we already have a function in the upgrade manager, which is to get the upgrade level, we can pass in the minor upgrade amount right here, and then easily use the minor amount upgrade to get the production we need. Get current production, and in here we're needing the current level. Okay, so let's pass in the minor amount upgrade level in here, and then we easily get the production we want to add per second. Minor production, which could be a double, I think. Pretty cool. But this is pretty repetitive because we need this for all of our shop items. I create another function calling it get production from shop item type, and I also pass in here the shop item type. This is a double, and then I just return that here. And because this is pretty specific with the minor amount upgrade, I just call it upgrade. This is the upgrade level, and then it should be okay. So now we have the double for minor amount. This is the minor amount, and then we can easily copy and paste this with the minor level and the stone level, and the stone level. And I would just say that we do it super easy right now without any big stuff. We're just adding that as multiplication, something like this. So let's see if this is working. But before we try to start that, we have to refactor our shop items again, because we added the item type and didn't set it. So this is the upgrade amount minus. So this is the minor amount upgrade minus. This is the minor level, and the upgrade stone is the stone level. And as you can see, we are getting a huge impact on that. Pretty cool. This is working great. So now we need to spawn these miners, so we have a visual of that. And in here we can distinguish between all these shop items. So let's say if the shop item is the item type of the minor amount, then we can go to the spawn manager and spawn a human. So pretty cool. This is working really good. You see, we're getting a mass amount of orcs, and now we can upgrade the miners itself. You see, also there's a bit of a balancing problem, but that's up to you, because the whole balancing stuff is a whole other difficult task to do. But you see, this is working as intended. Cool. So the next and maybe final step is to save the game, and when the game starts up again, we load the game and we calculate how much money was made in this idle time. And for that, we are switching back to our script in the idle manager, and we want to calculate this cash flow per second. I name that private double cash per second, and we can add the cash per second there, but we have to calculate the cash per second again with this multiplication. Cool. So we have a variable where the cash per second is getting saved, and we want to save this cash per second when the game gets shut down or gets paused. Also, we want to save the current cash, the current premium currency, and also the upgrade levels to have that. So for that, we create a new folder within our Unity editor in the scripts and I call that system. And in here we have a new script called save system. So we have a pile of work here to do, but first things first. We do not need to derive from mono behavior, so we can get rid of that. And because we want to save it from anywhere and the save system itself does not keep any states, we can make this a static class. So we have public static class save system. In here we can declare a constant variable as a string, and we can call that file name for the save data. So it's the file name save data. It's a JSON file. Of course, we could have any suffix we want or even use our own extension, but I think for now that's okay. Cool. So we want to have a public function which is called save game or save game state. Oh, I have a typo here. So at first we want to calculate, if you want so, the actual file path, which is for Unity games in the most cases something like the persistent path plus the file name for the save data. As autocomplete already suggests, we have the application.persistent data path, and then we're appending our file name for the save data here. So what do we want to save? We want to save the player state, the upgrade state, and the idle state if you want so. So for that, I just create 3 classes, which is the player save data, new player save data, we got the upgrade save data, and last but not least, we have the idle save data. We have to create these classes, but that's not a problem. So this is a public class player save data. At first, we want to make it serializable because we have to serialize this to a JSON later on. So this is serializable. Now we can copy and paste this one and use the upgrade save data and copy and paste it one last time for the idle save data. Cool. So now we have all these classes and we need to state what do we even want to save. So for the player save data, we said we want to save the current cache and the current premium cache. So let's make a new serialize field, which basically is a double for the current cache. This is a public double for the current cache. Again, we need this for the current premium cache. Now we need to make a new constructor which says public player save data. And in here we just pass in the player manager itself, call it player manager, and we say this.current cache equals player manager.current cache. And also for our current premium cache, we want to say player manager.premium current premium cache. So as this is not in here, we have a little refactoring right here to have it all clean and organizable. So I just copy and paste this one, but to be fair, I do not want to give it any real functionality as we do not use that, but just to be sure that everything is correct. Pretty cool. We can have its input here, which is the player manager.instance. Now the same for the idle save data. We have the serialize field for our cache per second. Of course, we need it, so we make it a property. Again, we need a constructor here. So this is the idle manager. And we say this.cache per second equals idle manager.cache per second. We want to pass in the idle manager.instance. And I see, okay, we didn't even have a singleton pattern right here. So let's do it real quick. For the upgrade save data, we need to do something else. We need to serialize an own class. So we want to have a serialize field where we have a list, private list of an own class, which I call upgrade level. And this is upgrade levels, and we can say this is a new list. For that, we need to create a new serializable class, which is called upgrade level. In here, we have the public int level and we have the public int ID. As you might imagine, we want to create a new constructor, upgrade level, level int and ID, and we want to provide the level and the ID. And now we want to have a constructor in here. This is the upgrade save data where we have the upgrade manager in, and then we want to iterate through every entry by going through each key value pair. So we have a key value pair where the first thing is a shop item, the second one is the level as integer, and then we just can call this item or upgrade in this case, and we want to iterate through the upgrade manager dot upgrade levels, and we want to add each of them to the upgrade levels. So for that we create a new upgrade level and add that to the list. So we have a new upgrade level equals new upgrade level, where we pass in the level, which is the value, and we want to pass in the key, which is the ID. And then we want to add this to the upgrade levels. So let's create another class, which is basically the general save data class. So this is public class save data. And in here we are creating new serialized fields, which is the public, and then we go through every new class we created. Player save data, upgrade save data, and last but not least, the idle save data. As all the other classes also, this needs a constructor where we pass in everything. Player save data, the upgrade save data, and the idle save data, and we want to have this just passed. Now in our save game state, we also want to have the upgrade manager right here. We want to have new save data, which is basically the save data with every new save data we just created. Pretty cool. And now we want to have that as kind of JSON text, which is possible with the JSON utility, and we can perform the toJSON call, and this will transform our save data class to a nice JSON file, and then we just write all of the text to your drive. Of course, this just saves the raw JSON file, and in a real production world you might want to have some encryption for that, but we do not handle that for now. We also want to save the current timestamp, so let's create another field, serialized field, and have that as a public int. So we have this current timestamp as a long, and then we say, okay, this dot current timestamp is the datetime now dot ticks. So we now want to really save our data. So for that we go to our game manager, and we have, I think, two options where the game is getting saved. When using the smartphone, we have the on-application pause event function and also the on-application quit function. So let's use both of them to say we want to save that. So on-application quit, this is a private void, and we also have the private void on-application pause. And we want to have the save system.save game state when the application is quit, and here we want to check, okay, how is the pause status? If it's paused, then we want to save the game state. So let's test this. I'm just happily clicking around and upgrade all my stuff to make some money in here to check if this is working. And now we have a little bit over 60k, 90k, 100k. So I quit it now and check if we have save data, and there we go. This is the JSON we get, and as you see, we have over 100k cache, 0 premium cache. These are the upgrade levels that we have, and this is the cache per second. This is not a real Unix timestamp, but it's a .NET tick, and we can convert that to the current date. So you see, when I recorded this, it's in the evening at the 3rd of January. And now we want to create the load system. So for that, we go to the systems folder, hit create, scripting, and choose mono behavior and call it load system. So in here, we delete everything. We delete the derived from mono behavior. We just make the class static. As I said, these load systems or save systems do not hold any state. And now we just create a new function called public static save data, and we call it load game state. So it's returning the save data object. We have a try and catch here because we first want to calculate the persistent data path combined with the save system.filename save data. And now we want to read everything we saved. So we get the file content, read everything from that file, but we're using system.io to have the right file class right here. And we do not need to decrypt it this time because, as I said, we do not have encryption in this content. So from the JSON utility, we get the from JSON function and convert our file content we read in here and convert it to a save data. Pretty cool. And now we can return the save data object. If anything goes wrong, we want to return null. This could be the case when this is a new game and we do not have any game state to load. And now we can go to our game manager and load the save game at the start. And if the save data is not null, we know, okay, there's something to load, great. Then we can invoke something like an onLoadData event function. I think this is the best way to do it. And if not, then not. So we have the onLoadData and choose invoke and pass the save data in here. Here we might want to add the public unity event with a type of the save data onLoadData. And this is a new unity event. So we might want to test that by simply going to the game state and print out everything in the file content in our debug log console to see if this is working. And indeed, you see the whole JSON in here in the debug log console. Of course, you won't see it in-game because we didn't load it programmatically, but the data is still there. Of course, if I hit quit, now the data gets overwritten and we lose our stuff. But it's okay. Now we got the proof this is working. We can remove the debug.log statement right here. And we can now go player manager. We can also go to our idle manager and to our upgrade manager and can add a listener to the onload data. So let's go to the upgrade manager in the awake function at the end, and we say game manager.instance.onloadData add listener, and we want to have a function which is private because we do not need it anywhere, and the function is just called load data. We can have the save data right here, and then we can access the data we saved. As we're just saving the ID, we might want to find a way to convert the ID to the whole shop item SO. And we can do that within the game manager because we have here in our shop items, every shop item. So we create a new function calling it public shop item, get shop item by ID, pass in the ID. And in here, we can just iterate through all these shop items. And this is a shop item. So we want to have the shop item right here, return shop item. And if the shop item ID equals the ID, then we want to set the shop item accordingly, break the loop, and then just return the return shop item. And we use this new function right here. So we get the key and then can set this accordingly. We want to iterate through everything as int upgrade level in save data dot upgrade save data dot upgrade levels. And now we can get the shop item by ID. This is the shop item SO. I just call that item for now. And I want to get it from the game manager. And we want to pass in the upgrade level dot ID. And now we have the key basically, and we can set this accordingly in our dictionary. So we say, okay, this dot upgrade levels, and we set the key, which is the item, and we can now say upgrade level dot level. And now everything should be set accordingly. And this load data we want to pass in this add listener here. And now when the add listener or the onload data event is getting invoked, our load data for the upgrade manager is getting called, so our values are getting updated accordingly to our saved state. And now we can do quite everything just like that for the other classes. We can do it for the player manager and for the idle manager. So let's do it real quick. We want to have the save data, but we do not have a list right here. So we can easily just say this dot current cache equals save data dot player save data current cache, and the same for the premium cache. So we can say the current premium cache, and now this also is working, but we also have to create an listener for that. So we have the instance for that, we have the onload data event, and want to create an add listener for that, and here we go. And one last time for the idle manager. This is really, really interesting for the idle manager, because here is getting calculated how much money we got while we were away. So we might want to also show that the player with a kind of UI element or something like that. But let's make first things first. Instance, then we want to get the onload data event and add the add listener, and we want to create a new event function for that. This is the load data. And now we can say, okay, the cache per second is equal to cache per second in the save data. So save data dot idle save data and cache per second. We're calculating the difference between the current ticks and the saved ticks. So I just call it diff ticks. And this is basically the difference between both ticks, the saved tick and the current tick state. And we want to have that in seconds, in full seconds, no float, so just the int. So we might have to cast the result to an integer. But first things first, we want to get the current save data dot current timestamp, which is a long, and we want to subtract this with the current datetime dot now dot ticks, and we want to have the result from that divided by the time span as ticks per second, as I said. So this is ticks per second, and we want to have everything right here casted to an integer. So this is the resulting statement, and yeah, let's see how many ticks that were. So let's say diff ticks, so we get the amount of seconds I've waited. And now the interesting part is how much money we made in this time. So let's call our format numbers function format, and here we want to calculate the diff ticks time this dot cache per second. So now we are getting the money we should get in our idle time. So let's have a look. Pretty cool. So now that we get our revenue while we were idle, we might want to have some kind of welcome back screen where we can tell the player what's going on in the meantime when he was not playing. So I just create a new game object and I call that welcome back screen. And it's totally fine to center that in the middle and scale it up as you like. I think it's okay to have it just this big, and we want to have an image here. And it's okay that this is just some basic stuff. This is not about polishing or something like that. It's just about to show you how this is working. So the next step is we have a little text here which says, okay, welcome back to this game. So in the meantime, I made it a little bit more beautiful and also added some kind of backdrop, and I will add a graphic raycaster to the backdrop so we cannot move the map or click some upgrade buttons when we are in this welcome back screen. So in our start function, we want to make sure that we set the correct amount on the revenue label, and also might want to move our UI element a bit so it has some kind of animation. So we want to have the welcome panel, we want to have the revenue label, and we want to have the backdrop. Instead of using the start or awake function, we're using the onEnable function because we have our object currently right in our game. This is right here, but we want to disable this at the start and want to enable it from the idle manager. So let's test this by disabling the welcome back UI and go to our UI manager. So with this function, we're able to toggle the welcome panel, but we want more than just toggling the welcome panel. So we're just renaming this to setup welcome panel. And this bool is called value, but show welcome panel. Now we also want to get the revenue text. That's it. We want to have the welcome panel dot set revenue text, and in here is the revenue text. Cool. So we want to create a new function in our welcome panel. So for our welcome panel, we also want to have some kind of revenue to give to the player. So we saved it to basically revenue. The public void set revenue function will take the revenue, and we can set the revenue label text with our format numbers format with the revenue. And here we are saying this dot revenue equals revenue. So we also want to fix this in the idle manager to just pass the raw double. Now we also want to make sure that it looks pretty good. So let's just call the onEnable function again and have the welcome panel first have to set the local position at the bottom of the screen, which equals to -screen.high. So we can say welcome panel.transform.local position, because this is a child object and we want to change the local position, and to have it a new vector, which is -screen.height. Then we want to animate this by using the transform.doLocalMove y, and we want this to end at the value 0, and this can take 1 second. And we want to set an ease type also. We want to set the ease type to outback, because this ease type is a little bit cartoony and I really like that. So I think the outback is fine for that. Also, we have the backdrop. We want to animate this. So we want to have the color as a new color because it's black. We can say, okay, we want to have it as 0, 0, 0, 0 also for the alpha value, because we do not want this to be visible at the start, but we want to fade it in. So you already saw in our IntelliSense, it said, hey, do you maybe want to use the fade function? And yes, we do want the fade function. We do not want the ease on that, but I think the end value of 0.75 to have it a bit transparent is pretty cool. And here we can also say, okay, I want to adjust this duration later. So I have the private float animation duration, which equals to 1 in this case. And now we can just paste this right here. So pretty cool. And with this setup, we should be ready to go to have this working. So now we also want to have the button have control over the welcome panel. So we might need to create another function, which is called give revenue. This function does three things. It first gives the player his revenue, then has the closing animation, and then really sets the active state of the game object to false. So let's try it by giving the player its money. So it's player manager dot instance. We might want to import that right here, and then add some cash to the current cash. So we want to add the revenue. We then want to transform the local move y again back to the minus screen dot high. We can also do that with an ease. That's totally fine. And then we want to have an on complete delegate, which basically is a lambda function. So we can have some code right here, and we want to say, okay, when this all is over, I want to get this game object to be not active anymore. And yes, also for the backdrop, we want to do the same. We want to have a fade, but again, back to 0. Let's head back to the Unity editor, and we go to our button, which is this continue button right here. And then on the on-click event, I just hit the little plus sign and move in our welcome back game object and take the welcome panel here. And here we have the give revenue function. And you see, hey, we got 100K right here. But if we hit continue, we should get 3.89 million in cash. And you saw the little animation. I really like that. And now when I hit continue, we get the 4 mil, and also the backdrop fades away and the panel also animated to hide. So these are the very, very, very basics of an idle game. I hope you liked the tutorial. If you liked the tutorial, then I would be glad if you subscribe to the channel, and if you have any questions, feel free to ask down below. These longer videos are a hell of work, so I really appreciate it if you support me with a subscribe, or yeah, let me know in the comments what you want to see next. Thanks for watching. We see you in the next video. Bye.